I apologize up front. This will probably not be that interesting to you if you've ever already added an index to a database, but um, sorry. Sure. Me. Okay. Anyway, so I apologize if this is boring to you if you've ever had any kind of serious use of our database. But in my experience, I've met a lot of developers that really have no idea what indexes are or why they're really useful. Just kind of give you a really brief overview, a really simple sample case, and a couple pointers, and we'll call it a night. So the first important thing is we're going to talk about what are indexes. I'll tell you why they matter, and then show you a little bit how they're created. But basically, these are like a specialized data structure that makes it very easy to search through a database very quickly and avoid scanning every single row in your database, right? So if you are a very successful, work for a very successful company and you have lots of users, your user table is going to have thousands or hundreds of thousands, right? If you do financial transactions, right? You do hundreds a minute, suddenly your database table has millions and millions of rows. So the reason why indexes matter, this is a very simple case from some code. So I recently started a new place called Analyte Health. Thank you, Lordy. And my boss came up and he's like, hey, there's all these really annoying things showing up in the slow query log, right? So MySQL, as a database that we use, will you can set a threshold, and then any queries that take longer than this threshold show up in this log. And he's like, there's all these things showing up. And I found the query, and then I found the point in the code that was causing it. And you can see here, we have this view, and it's showing all these purchase events and kind of a dashboard. And this is like maybe like 1/20th of the code. But these are the relevant parts. So it has this query, it does some filtering, then it jams it in a paginator, and then we fetch the first page, or if we're fetching a different page, we'll get a different one. And this is what really hurt us. So we were gaining a performance benefit from the paginator because it was only fetching a certain subset of the records at a time. But for the paginator to do its work, it needed to know how many records there were total. So it does this really simple query, and just gives us a count of how many records match. So the original execution time for that query, just to fetch the number of records, was 12.6 seconds, which is forever in computer time. And I did a little magic, and after I was done, it took 18 milliseconds, which is... I'm that awesome. So as you can see, like that was 700 times faster than it was before. And my boss was like, awesome, can you find another slow query? I said, well, let me explain to the team why this magic worked. So this is the code that we were talking about. And this is our query that we ended up with. So it's pretty simple. We're going to select, we're going to get a count of all the rows. We have two filters. There's a flag that tells us when it was cleared, and then what type it is. And I use this little magic keyword called explain. So I literally just put that keyword explain in front of the query, and I ran it, and then MySQL gives me back all these helpful pieces of information, some of them maybe more helpful than others. But a couple things that are really important is it shows us which possible indexes are going to be used. MySQL calls them keys. Sometimes it calls them indexes. It's really the same thing. It shows us how many rows that it's probably going to check to get to our result. And then the extra field here also tells us some information about how it's going to run that query. And the important piece here to look is it says using index condition. And so you might think, well, it's using an index, so it must be pretty fast. But you see it's not really, because it's actually going to go through 5.8 million rows to give us our result. So if you look at the query I've highlighted here, that we have two different columns it's going to look at in the where clause. So there's two different conditions it's going to check And we have a match on both of those conditions, it's going to give us a row back from the database. So in MySQL, you can just go in and you can alter your table and just add an index. And you can see here, so an example, I built an index using both of those columns that are important to me. In Django, we use Django in our office. Anyone else use Django? Like 2 people, 4 people, 20 people? Okay. So there's a couple different ways to add indexes in Django because it sort of abstracts away some of the database stuff. You know, you specify like I want an index in the code. One way is on if you want a single field indexed, you just say db index equals true, and it, you know, MySQL's migration code will then make an index for this field. In your model's meta information, you can add index together, and that you can tell it index these 2 columns together. You can give it a list of column names. You know, you can do 2, 3, 4, 5, however many. That makes your day go that much better. So in Django 1.11 and newer, they added a special index class. So you can add it. The syntax is not really that much different, but it's a little more explicit. And if you look at the second index added in this list, the nice thing is it allows you to name them. Django will automatically name them for you, which can be handy, but sometimes the names are really hard to decipher. So you can explicitly name them, which I find very useful. But after you add indexes in the code, don't forget you've got to have Django generate the migrations and also run them on your database before those indexes show up. So again, this is what we did. We ran explain on our old query before the indexes were added. And so there's 2 possible keys here. One is on the purchase event type ID. That was a foreign key on our model. And so Django, or not Django per se, but in MySQL, when you have a foreign key relationship, you automatically get an index. And also the purchase event date time had db index equals true. So, you know, Django created an index for that field, but just one or the other. You see here I made a note that it's a flag cleared date time, and this is the name that Django automatically generated. And it's using this index condition. And what that means is that it will do part of the query using an index, and then the rest of it has to go through each row one by one and check the other condition. Okay? What you really want to look for is using index. When it just says using index, that's when things get golden. And now this is after I added that index where I took both of those columns and said make an index with both of those pieces of data together. So you can see here Django generated this really long name, and then MySQL decided, oh, I'm going to use this index because it has both pieces of data that I need to check for in it. And now you can see it actually looked through a very precise number of rows. So before it was filtering 5.8 million rows to get down to the 3,000 we actually needed, right? And you can see here the magic keyword using where, using index. Any questions so far? No? Okay, great. So now we know what indexes are. Now we can see really why they're important, because if you can do a query in 18 milliseconds versus 12 point seconds, any user of your application is going to be much happier, that's for sure. In our case, this was actually the dashboard was an internal tool that we're using. So, you know, when you have like 30 people, including the CEO, that needs to check this dashboard every day, and they're like, "Hey, this takes forever." Yeah, when you make it faster, you look like a champ. So there's some important considerations. Like first, you might like, well, just index everything, right? But indexes take up space, right? So in your database, every row, every record, that takes up its own space, and then the indexing also takes up additional space. And the more indexes you have on a particular table, every time you go to insert or update a record or delete a record, then it has, you know, your database system has to go in and does the index need check it? Does the index need to be updated, or does an index entry need to be added? So you don't want to index everything. You want to try to find a balance, right? So kind of the rule of thumb is if you're doing queries where columns end up in that where, in the where clause, or in Django, if you're using a filter on a particular field, or whatever particular ORM you're using, anything where you're doing filtering conditions, you want those columns to be indexed. When you're doing queries that have multiple filters happening, you want all those fields to be in the index. So you can make indexes with, like I said before, it can be 2 columns, 3 columns, 4, whatever is needed to make your query really fast. And the order does matter to some degree. Optimally, you want them in the order of cardinality, and so that means like how many unique entries will be in a particular field, like a date time field. Almost every one of those is going to be unique, almost, right? So let's say you're going to do 3 columns together. You do the one with the most unique data, then the second most unique, and the third most unique. That's the most optimal way to do it. And then the order of the columns in your query then don't have to be in that same order. But as long as all the columns match all the columns in the index, then the query planner can use the index strictly, find all the rows very quickly. But then what about queries that don't need all those columns? This is a kind of an interesting thing. It took me a while to learn. But if you have an index on, like, say, these 3 brilliantly named columns, 1, 2, and 3, like I said before, they can. So your filtering conditions can be in any order. So it could be, column 1, column 2, and column 3, or 2 and 3 and 1. Doesn't matter. But it also works if you do a query where you're just doing a filtering on that first column. It will use this same index. Okay. And it'll also work if you're doing a filtering on column 1 and column 2. It can still use the same index. So if you have some queries that use all 3, then also that use the first 2, and then some that use 1, you only need that one index to cover all those scenarios. But it doesn't work if you're going to filter on the second and the third column, right? Okay, so if you're only going to filter on those 2, then you would need a separate index to optimize those. The same thing if it's 1 and 3, right? You need them to be either all 3 or the first one or the first and second one. And then also OR queries, it's going to use, it's only going to use the index for part of the result, and then it has to do the same thing, scan through those results. But still, the index will give you some speed up. Yes, question?
Isn't it just going to use one of the indices to select the records and then filter the rest just as it goes?
In which particular case?
Where you're doing several selections.
Right. So it'll depend. Like, if you're talking about a single table, and all of your where conditions are in the same index, it'll use that index. If you're
not even in the same index, it's just if you've selected by one index, and then you don't necessarily have to have the other comparisons.
right. So
it's just going to whittle down your number of records.
right. So if you're doing a query that uses just column 1, it will still use this. It can still use the same index. If you have this 3-column index and then a separate index just on column 1, then the query planner will also have to decide which one would be more efficient to use, right? So that's why just putting on a whole bunch of different X's can sometimes increase the time, because then now the query planner has to do more work to decide which of these indexes would be most efficient. So, like I said, some people, in my experience, a lot of times most people don't really understand that indexes matter. So there's none or very few, and the complicated queries take forever. And then the first thing you do is you learn about indexes, and a lot of people would rush to just let's index everything, woohoo! But really, you got to find that, and it takes practice.
I would think it'd really kick in when you do a join.
Yes. Yeah, so when you do joins, then it'll start to use multiple indexes, and sometimes it'll use an index from one table versus the other, and it gets a lot more complicated there, for sure. Um, some other kind of side tidbits. Again, I talked specifically about MySQL, and it has basically just one basic type, or that it uses most of the time, just a binary tree, right? So if you've ever had the pleasure of taking a computer science course, maybe at a university, you probably had to like study binary trees and how to traverse them and add elements and remove elements. That's what your database does. If you're indexing columns that have text in them, the most common MySQL engine, InnoDB, has a byte limit of 767 bytes in the index, so you can't do a full text index. Practically speaking, what that means, if you have UTF-8 columns, and in MySQL, they mean characters that only use 3 bytes, you can have a 255 character limit. If you're using actual full UTF-8, that's 191 limit. So sometimes, if you're indexing a text column and it's really long, you have to decide like what's going to be most efficient. Like I'll index the first 100 characters or the first 120 or whatever makes sense for your needs. If you're using Postgres, like all smart people do, sometimes we don't get to make these choices. But they have some other indexing options that were recently added, like Postgres 9 and 10 have added some new indexes that you can play around with, and Django provides classes that allow you to set up these types of indexes. But they're, to be frank, they're complicated, and I don't know that much about them, so I'm not going to pretend like I do. But if anyone here is interested in learning more, feel free to ask me. I probably don't have the answer. But there should be a link to the slides on the Chippy page, and I'll throw one up on Twitter. But here's just some really quick links that I think will get you started in the right direction. And I'm happy to answer any questions if anybody has any.
So you were talking about exploit extends for MySQL?
Yeah.
What's the keyword for Postgres?
Postgres, you can use explain, but an additional keyword that Postgres offers is called analyze. So you can do explain analyze. And it will literally step you through like here's all the indexes I considered, and here's the algorithms I considered to optimize it, and here's the ones I chose, and here's why, and here's how many records. Like it's it gives you much more information to work with, so you can really kind of understand a little bit more about what's happening under the hood. Unfortunately, MySQL just gives you just the explain, and the extended tells you like which of those conditions it'll use, and like I said, you want to look for that using index. Yes?
Does Maria database expand on that any?
I don't believe that it does, but I don't know. The question, if you guys didn't hear that, he was asking about MariaDB, which is more or less kind of a fork of MySQL. Some people might say the future of MySQL. I don't think that it adds anything additional at this time. Yeah.
Would there be any value to putting a multi-column index on something that's already a primary key?
Yes. So the question was, is there any benefit to adding a multi-column index if there's already a primary key? If you're going to query on primary key and some other condition, then having that other index can help. So typically, I would say a primary key, usually you're like fetching, like get me this one record that matches this primary key. And so an additional index won't really be that much use. But if you do queries where it's like, give me records where the primary key is in this set, plus also this other condition is met, that's where an index might be really helpful there. Anything else? No? Oh, right over here. Sorry.
How would you optimize if you have like 5 tables you're joining against and they only have about 20 records in each?
That's probably not honestly going to take that long. Sorry. The question was, what if you're joining across about like maybe 5 tables, but there's not really that many records? An index, you probably wouldn't notice a difference in an index with that. It's usually when you start to see like, and it's going to vary depending on your data needs and how you're fetching them. But when you start to see like record numbers in like the hundreds of thousands or millions. To give another example, not to speak ill of my former coworkers, But in my previous job, we had this giant SQL query that was run by a cron job to update Salesforce data. And it had to fetch something. It was like it joined like, I think 19 tables, if I remember correctly. Like it was a crazy, it made this huge CSV file and chucked it up to Salesforce. And the query took like between 5 and 6 minutes to run. And then it took like, sorry?
How much of that was planning time for it to guess it right?
I couldn't tell you, to be honest. But it was a cron job, and it ran every half an hour, and the query took 5 minutes, so like no one kind of really noticed. No one really noticed that it was a problem. Like, we had these, we had like 5 read replicas, and we're handling like thousands of database reads, so it wasn't like no one really paid attention until the sales team was like, hey, we need to get this other data into Salesforce. Can you just like add these 2 pieces of information? I was like, oh, I can add those 2 lines of the query. And then suddenly the query wouldn't run. We had a 10-minute timeout on our servers, and the query just wouldn't, it would time out 10 minutes, like, oh geez. Now the sales team's breathing down our necks, like, why isn't this implemented yet? And so sure enough, I was adding some aggregates to fetch those 2 pieces of data, and aggregates can sometimes take a lot of time. And so I sat down with another guy on my team, and we just tried some different things, and we realized that the query itself was like using a datetime function to get records within a certain datetime range, that's a bad idea. Like, so it had to execute that function for every row in the table, calculate a value, then do the comparison. So I rewrote it so it pre-computed a value and then checked to see is the datetime greater than or less than this pre-computed value. That sped it up. And then I just added an index on some column that was missing from the where clause. And the query wouldn't run at all, now ran at 80 milliseconds. What had previously taken 5 minutes every half an hour, and it was now taking 80 milliseconds. So actually our infrastructure team was really happy about that. Because that freed up, while that query is running, right, it basically can't really run any other queries. So that particular read replica was just busy running that query for 5 minutes and not doing anything else. So by just simply adding that index, I was able to run that whole query and get those aggregates into the table, and then I was again a hero for just adding an index. Like that's all it took, and I didn't have to fly or anything. So anyway, that's my fun index story. Question, yes?
You talked about the multi-column index and the efficiency in the order that you build that.
Yeah?
What about the efficiency in the order that you query those?
So I think I kind of glazed over this point. The question was like, does it matter the efficiency in the order you put your conditions in the where clause? And no, as long as all of the columns are, so like the example I showed was like 3 different columns indexed together. As long as all 3 of those are in some particular order, it will use the index. And the same is true too if you're doing like group by or ordering by. It can also use the index to speed up those kind of sorting operations as well.